We are solving ISS 2022 paper 2 question number 79 and 80. So let x1 to xn be a random sample of size n from b1 theta Bernoulli distribution, and let y is equal to summation of xi be complete sufficient statistics for theta. Then umb of theta is, and in question number 18 umb of theta square. Okay, so we have given the following information. x1 to xn is following Bernoulli distribution with parameter theta, and y is equal to summation xi is given to be complete sufficient statistic for theta. Okay, so we need to find MBUE for theta. So what is MBUE? So MBUE basically function of sufficient statistics which are unbiased. Okay, so we need to find a function of y which gives this expectation as equal to theta. So we know that if x1 to xn is following Bernoulli, then summation of xi will follow a binomial distribution with parameter n comma theta. This further implies that expectation of y is equal to n theta. Now since theta is a parameter, n is constant, so we can put it in left hand side, and we are getting expectation of y is by yn is equal to theta. So we have found that a function of y which is unbiased for theta, so this will implies that yn is MBUE for theta. So for question number 79, option A is correct. Now MBUE of theta square. So just apply the same principle. We need to find the function of y which is unbiased for theta square. Okay, so we know that in case of binomial distribution, variance is given by n theta 1 minus theta. Okay, so we are getting n theta minus n theta square. Okay, so we are getting this a function of theta square. So we need to tackle this and we need to find function of y which is unbiased for theta square. So how do we do this? So variance of y is related with expectation of y square. So further we can rewrite like this: expectation of y square minus expectation of y square is equal to n theta minus n theta square. Expectation of y square will be, now take it into the right hand side, n theta minus n theta square. Expectation of y is n theta. This means this is n square theta square. Okay, so we need to remove this theta. So how do we remove this? So write it like this. Okay, because expectation of y is equal to n theta. Now we have common n square here. So if you common n square, suppose common n theta square here, so we will be left with n minus 1 here. Okay, now take it in the left hand side, so we will be having y square minus expectation of y is equal to n minus 1 theta square. So this is constant and this is parameter, and so we can common here y, so we are getting y minus 1, and put it in the left hand side, we are getting n minus 1 is equal to theta square. So now we have found a function of y which is unbiased for theta square. Okay, so y MBUE, so y minus 1 and n minus 1 will be MBUE for theta square. So for question number 80, option B is correct.